In this video, we shall discuss case 25 mathematics question number 64 solution. And this question is group theory related question. Okay, so let's see the question first. The question reads as follows. Suppose G is a group with identity element and G and H are two elements of G such that G is equal to identity but H square is not equal to identity. But the point is that conjugation of H with G is equal to H square. Now the question is we need to find the least positive integer n such that H to the power n equal to E. Okay, that is we need to find the order of H. So that is the question. So before starting the question, let's see what are the important theorem for solving this problem, or also let's see the NOC course references in which you can find the study materials regarding this problem. Okay. So this course 1, course 2 are these two courses covers the desired material for solving this problem, and these two courses are offered by Professor R.V. Venkatas and Professor Krishna Ramanathan, and the relevant lecture numbers are displayed. You can go through these lecture numbers and you can find the necessary study materials. Okay. So now let's see the important theorem which are useful for solving this problem. The first theorem is that it is automorphism of conjugation. That is, for any G belongs to G, we have the map CG of X, GX, G inverse. This is an automorphism. And CGXY is equal to CGX into CGY. That means CG, this CG is a group homomorphism. Let me write it down. It's a homomorphism. Okay. And moreover, this thing has a property that if G square identity, then CG, this map composed two times, is an identity map. And this is one theorem. And second theorem is that the dihedral group representation. So this is D2N, usually denoted textbooks. This are generated by RNS, and this is the relations. Rn is equal to identity, S is equal to identity, and S or S inverse is equal to R inverse. And D6 is equal to S3. It is a very well known result. Okay, so this is the dihedral group representation. That means if we have some groups where if we're able to find two elements satisfying this relation, that means immediately we can say that group is nothing but isomorphic dihedral group. Okay, so that's what this theorem tells. So now let's see how to solve the problem. Okay, apply the map CG to H. Okay, that is CGH equal to GH G inverse. It is by definition. Okay, now CG whole square of H, this is by definition CG of CGH. Now observe that by given question GH G inverse equal to H square. It is by given question. Okay, that means CG of H, that is equal to H square. This is coming from the given hypothesis of the question. Okay, now CG whole square H, this is nothing but CG of H. It is by definition, so equal to CG of H square. Okay, now CG of H square equal to CGH whole square. Why? It is by homomorphism properties. Okay, and this is nothing but H square whole square. That is H to the power 4. But the point is that since according to the question G square is equal to identity, so this implies CG whole square, that is identity map. And this implies what? This implies H equal to H to the power 4. Okay, and that implies H cube is equal to identity. So from this we can say that order of H, this is equal to either 1 or 3. Okay, but order of H cannot be equal to 1 as H not equal to identity, it is given. So this implies order of H is equal to 3. And so this tells that N is equal to 3. So this is the answer, okay? So this is one way of solving this problem. There is another way of solving this problem using the structural diagram group. So let me explain. G square is equal to identity and G inverse equal to H square equal to H inverse. So this is the relation in the dihedral group. And with this generators following these relations. Now in the question, if we take H equal to R and G is equal to H, then it is clearly that G and H satisfying these three relations. Okay, that means let me write it down. These three relations are satisfied by G and H. By putting G is equal to S and H equal to R. So that's why the given group is nothing but dihedral group D6, and that is directly tells that order of H equal to 3 and order of G is equal to 2. So this is another way of solving this problem. Thank you.